All right, so I think this is recording. We have been looking at skill 3, which is relations and functions. And in one of those sub-skills, we were looking at the operations on functions of how you can create a new function using two old functions, or maybe even more than two. And the our expectation was, well, I'll bet you can add two functions together to get a new function. Yes. I'll bet you could subtract two functions and get a new function. Well, that's true. You could multiply two functions together and that'll produce a new function. You can divide two functions and that'll produce a new function. Well, then there's this new operation that we've probably not seen before except in an algebra class, and that's called function composition. We take our number that they give from the domain and plug it in one of our functions. We take that output and it becomes the new input into the other function. And then our final answer from that is the answer for the composition. So I've had success in getting students to kind of mentally think about function composition like an assembly line. And the notation is something that can be awkward when you first learn it, because normally when you read things, you read from left to right. But when we're looking at function composition, we actually go from right to left. So when we see this h composed with g, that little circle does not mean multiplication. Then we start with the function g, plug in 1, get that output, and plug that number into h. So you guys have shown that you're very good at evaluating this function when it's a number like 1. So we think of it, students often rewrite this like this. Okay? And like I say, I've had success in trying to get students to think of this like an assembly line. Or maybe they'd call it a conveyor belt. I don't know what they would exactly call it. But the first function is g, and the second function is h. And here, our input is coming from the domain of g. Well, G's domain is all real numbers, so we don't have to worry about avoiding any number. And here, they're telling us to plug in the number 1. So if x is allowed to be the number 1, what does this function g always do? G always takes whatever you give it, and it creates an addition problem, where the first term is -3 times the input cubed. And then you add the input. Well, sometimes we've seen that the input is some crazy expression, but for here, it's just a number. So on the right hand side, all we have to do is this arithmetic. And I'm actually pretty good at arithmetic with zeros and ones. 1 cubed is 1. -3 times 1 is -3. -3 plus 1 is a -2. So the output of g is a -2. And that now goes into h. Well, we have to think, what does h do to the input? H always creates an addition problem as well. So h will double the input and then add 5. So what we're inputting into the h is a -2. So we're going to double that and add 5. When I double -2, I get -4. When I add 5 to that, I get a +1. So this intermediate value, g evaluated at 1 was equal to -2. H evaluated at -2 had an output of 1, and there's our answer for this problem number 1. Now, problem number 2 and problem number 3 and problem number 4 are done in a similar manner. And the answers that you should get, well, I've got that answer key posted on Edline. Now, I think I accidentally called this one day 1, and actually this was the second day of our function compositions. So if you don't mind, for now, I'm going to jump to problem number 5, because now problem number 5 is a little bit different. The input is not a number. They want me to find the formula for this composition. Now, in our assembly line of functions, you can have a machine here that's function h, and you can have by an identical function h, where they do the same job. Well, what do both of these functions do? These functions are very good at creating an addition problem. So how does it create our addition problem? Well, it needs two numbers or two expressions to add together. If we give this function, whatever we give it, it's going to multiply the first term by 3 and then add 4. And whatever we get over here, it's going to multiply the first term by 3 and then add 4. That's what it always does. It always does the same thing. It multiplies by 3 and then adds 4. That's what h does. So here is the input. In the previous problems, that input was a number. But now it's just an expression. It's just a variable x. If you input x, and let's put it in a different color. Let's just go ahead and put it in black. Well, change the pen. If I input x into this function h, well, what's going to come out is 3x plus 8. Excuse me, plus 4. So that's the output of h. That's what this says right here. But what if we input 3x plus 4 into h? Well, this time the input is 3x plus 4. H always multiplies by 3 and then adds 4. So it's going to multiply. I didn't leave enough room here. It's going to take this 3x plus 4 and multiply it by 3 and then add 4. So 3x plus 4 multiplied by 3 is 9x plus 12. Then we add 4 to that, and what comes out of the final product of this assembly line of two functions here is 9x plus 16. So we hope we see that among the choices, and there it is. So I claim that h composed with h has a formula that is 9x plus 16. I could use that formula instead of going through here. Let's real quick, even though the problem's not asking it, let's turn it into a problem like yesterday. You guys loved the problems from yesterday because what you liked was plugging numbers into this. So I'm just going to plug in the number 1. If I plug in the number 1 to h is going to multiply it by 3 and add 4. That's what h always does. 3 times 1 is 3, and 3 plus 4 is 7. H is going to multiply by 3 and add 4. 3 times 7 is 21, and 21 plus 4 is 25. Now, what if I didn't, what if I just wanted to cut to the chase and say, yes, 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 I know that intermediate number is 7. Hey, when I give it 1, just tell me what the answer is. Don't go through this whole process. Well, I'd sit there and say, all right, if you plug in the number 1, then this function composed with itself will be 9 times 1 plus 16, which is 25. So I didn't have to go through that intermediate value of 7. This time I had the formula, and I just plug in my number into the formula directly, like we've always evaluated functions. Or to find the composition, you can break it into an assembly line. So hey, I hope that helps. All right, so let's see if we can't find a few. A lot of people asked me about this one today, so let's talk about it. We're composing a function with itself. So we've got this function f, and right next to it we have another f. And we're going to input the value of a, and we need to see what we get as an output from this assembly line. Well, what does f always do to whatever input you give it? F is very consistent. F creates an addition problem, where the first term, the first number, it always gets by taking negative 3 times whatever number or whatever expression you give it. Negative 3 times that number squared then plus 3. Well, this f does the same thing. The first term is negative 3 times the input squared plus 3. So we're giving it not a number like 2 or 4, we're giving it a. So it tells us right here that if you give this function a, you'll have as an output negative 3a squared plus 3. So, but it doesn't tell me if my input is negative 3a squared plus 3 what the output is. What if the input is negative 3a squared plus 3? F doesn't care. It doesn't matter what we give it. In fact, it doesn't matter at all because the domain for f is all real numbers. Whatever we give f, it will create an addition problem by taking negative 3 times the number squared plus 3. So we've got to just now do this algebra. We need to take negative 3 times, when I square negative 3a plus 3, it means negative 3a plus 3 times another negative 3a plus 3. Now some people may prefer to multiply this out in the form of a table. You might write out the word FOIL. There's various ways. The underlying mathematical property is the distributive property. That's how we're able to multiply these two binomials. So a negative 3 times a negative 3 is positive 9a squared. Then I'm going to have a negative 9a and another negative 9a for negative 18a, and then 3 times 3 is 9. Don't forget to add the 3. Alright, so I'm back. So the output, let's distribute this negative 3, which is a negative 27a squared, a positive, I think, 54a, because 3 times 8 is 24, carry the 2, 3 plus 2, yep, and minus 27 plus 3. Well, I can combine those two terms. So I believe that we're looking for an answer among our choices that is negative 27a squared plus 54a minus 24. And we see that right here in choice D. Alright, let's see if we can find another one that's kind of interesting. I think that you'll be fine on this one. Should be fine on that one. Some people asked me about this one today. Let's take a look at it. So we've got G composed with H. We want to take the function H and plug it into G. So we have this function H, and the input to H is going to be A. And the output of H, well, it tells me here in this equation that when you give H an input of A, the output is A minus 2. H always subtracts 2 from whatever you give it. Well, now we're going to take this A minus 2 and we're going to feed it into G. Well, what does G do with any input? G creates a subtraction problem. And G is a little more complicated because the first number of this subtraction problem is the input, no matter what it is, cubed. And the second number is the input squared. Okay? So when that's a number, it's not very difficult at all to, if that was the number 5, to take 5 cubed and see it as 125, and take 5 squared and see it as 25, and 125 minus 25 is 100. But it is harder to do when we have a variable expression, because we have to take a minus 2 quantity cubed. Now a minus 2 quantity squared is easier, but this cubed, a lot of people ask me about that today. So it's almost a problem within a problem. So right now, let's come over and just figure out what this expression is going to be. And in the process, we're actually going to find a minus 2 squared, because down here is my scratch work. I know that a minus 2 quantity cubed means a minus 2 times a minus 2 times a minus 2. And when you multiply a whole string of things together, just start on the left and multiply from left to right, multiplying two things at a time. So the first thing I'm going to do is multiply these two binomials together. And for most of us, we can just look at that and say it's a squared minus 4a plus 4. Now, if you can't just look at it and do it, well, then come over somewhere and create a table that has a minus 2 and a minus 2. And from the entries of the table, a squared minus 2a minus another 2a and 4, you can see along this diagonal is how I got minus 4a. And along the other diagonal was the a squared plus 4. So you can definitely do it. You may not like doing it, but it's not that difficult. It is a little more difficult to take that trinomial and multiply it by that binomial. So even I'm going to do this in a table. I'm not embarrassed to use the tables. It's just that I've multiplied so many binomials together, I really don't need it anymore. But to multiply a trinomial times a binomial, I need a little more organization. So I like the table because it helps me be organized as I apply the distributive property. Because this a, every term in this trinomial gets multiplied by a. That's what this top row is going to do for me. A cubed minus 4a squared plus 4a. So now I come to the next term and I distribute it through this trinomial. Negative 2, everybody gets multiplied by a negative 2. And again, the table helps me be very organized in how I do that. I don't want to make a sign error. A negative times a negative is positive. And over here, a negative 8a. Well, now the table even helps me combine like terms because look at those diagonals. Those diagonals are like terms and I can add them together. Alright, so I've got this a cubed and I've got this minus 6. Now wait a minute. See that cube right there? I don't know why I wrote that. Maybe you were yelling at the video. When I had a squared times negative 2, that should have been negative 2 times a squared. Sorry about that. Alright, so this negative 2a squared and negative 4a squared is negative 6a squared. And this other diagonal, 4a's plus 8a's plus 4 more a's is 12a's. And then minus 8. So that was a lot of work just to find this first term. Remember, it was a problem within a problem. This is just scratch work that we did to figure out what the first term of our subtraction problem was. So when I return to this g evaluated at a minus 2, I've now done the work for a minus 2 cubed. It's over here. A cubed minus 6a squared plus 12a minus 8. And I got pretty lucky because a minus 2 along the way, well, the a minus 2 is right here. I take that back. A minus 2 quantity squared. A minus 2 times a minus 2, we did that in the process of finding this a minus 2 cubed. So we know what the second term is. The second term is a squared minus 4a plus 4. So we're ready to figure out what our final answer is. Over here, we just have a cubed, and there's no other a cubed that we're taking away from it. We've got the negative 6. Let's combine our a squareds. We've got negative 6 of them there. We're taking away one of them. So we have negative 7a squareds. So we've got this. What about this 12? Well, we're going to take away 4, and 12 minus 4 is 8. I take that back. I just made a mistake. We've got 12a's negative 4a's, but when you take away negative 4a's, the double negative is the same as adding, and 12 plus 4 is 16a. I almost made a silly error there, didn't I? And now negative 8 minus 4 is a negative 12. So hopefully I haven't made any silly mistakes. I almost did. And that's one of our choices. Um, looks to be choice A. Alright, so I hope that helps. Let's see if there's any others that jump out at me that I can do this evening while you guys are probably getting ready for your Christmas spectacular presentation. Or real shortly, maybe you've got an hour still. Maybe you're maybe you're a little bit nervous right now. Alright, so we're taking H and we're plugging it into G. That's not that bad. Going the other way, taking the 4 minus x and plugging it into H would mean cubing 4x minus 4, and again, we'd have to go through that process. But G composed with H is the easier direction, so I don't think you'll have problems there. Now, taking G and plugging it into H. Now that one's going to be another challenging one, right? So let's do that. You've got this function G, and you're inputting in. And what does G always do to the input? Well, it tells us in this formula right here, it takes 3 times the input and adds 2. Now we're going to take that 3n plus 2 and we're going to input it into H. Now H is not as easy and convenient as G was, because H creates an addition problem, but what H does is it takes your input, no matter what it is, in this case it's this 3n plus 2, and it cubes it. And then it adds 4 times in that input squared. So we need to figure out, once again, 3n plus 2 cubed and 3n plus 2 squared. Then we'll combine like terms and we'll have our answer. Alright, so we've got some scratch work to do. Alright, so 3n plus 2 cubed means 3n plus 2 times 3n plus 2 times 3n plus 2. And when we do that, we just multiply and get our answer from multiplying the first two together, those binomials, and then take that answer and multiply it by 3n plus 2. When you multiply this, if you do it in the form of a table, or if you spell out the word FOIL, or however you multiply this, 3n times 3n is going to give you 9n squared. 3n times 2 is 6n, then you're going to have another 6n for a middle term of 12n. And then 2 times 2 is 4. So now we need to take this trinomial times this binomial. And remember, all of that we're doing here is just to figure out what this first term is. We actually just figured out what the second term, the 3n plus 2 squared, is. It's this guy. Now I'm going to come up here, just because I have room up here. I've got my 3n plus 2. And I have my trinomial n squared, 12n, and 4. So this is an organized way to help me apply the distributive property. 27n cubed, 36n squared, 12n, 18n squared. See, I didn't say n cubed that time. 2 times 12, 24, and 2 times 4, 8. And along this diagonal and that diagonal are common terms. So I claim that this trinomial times this binomial is 27n cubed plus, well, 18 and 36. might be 54. And then 24 and 12, that should be, I think, 36. Now, you might want to check me on that. All right, so, well, it'll check what it's, if I don't get the correct answer there, right? So all of this was just for that first term. So let's shrink this up. It's my scratch work. Move it out of the way. That work was done because 3n plus 2 quantity cubed is this guy. 27n cubed plus 54n squared plus 36n plus 8. Now, I have plus 4. When I squared it, I found out what it was squared right here when I took 3n plus 2 times another 3n plus 2. There's that square. So that's the second one. So thankfully I don't have any more work to do. I can use the work that I've already done for the cubed for this squared part. So I have this 27n cubed plus 54n squared plus 36n plus 8. And now, inside this trinomial, everybody gets multiplied by 4. I've got 36n squared, 48n, and 4 times 4 is 16. So I've got 27n cubed, and here I've got 2n squared, so I add those together, and I think I'll add up to 90n squareds. Then I've got these n's there. What do they add up to? Maybe an 84. We'll double check it if I don't get an answer up there. And 8 plus 16, 24. Alright, so let's drum roll, please. It looks like it's C. And hey, we got the right answer. That's C. Alright, let's thumb through here and see if there's any more that are of interest. Now there's a cube, but this time it's easier because we're not taking f and plugging it into the one that's cubed. We're taking this g and just doubling it and adding 3. So that one is much easier. If they had asked us to find golf, g composed with f, that's more challenging, and that's going to be like this one. It's going to require us to do a lot of scratch work. Alright, so let's look here. So g is being plugged into f, but this time g is so simple, it's not a binomial that you're cubing. So let's do this one, but I'm expecting it to be much easier than this problem. It's the same idea, but the algebra is going to be much easier. So I want to take the function g, and we say plug it in, substitute it in to the function f. So what does g do to the input? If we give it t, this equation tells us that g always doubles whatever you give it. We gave it t, it's going to double t. So now we want that to be the input into f. Well, what does f always do? See, now I want to evaluate f at 2 times t. See, there's that intermediate work. Now, what does f do to the function? Well, f is a lot more complicated. F takes the input no matter what it is, and it creates an addition problem. But for the first number, it takes the input no matter what it is, and it cubes it. And then it adds 2 times the input squared. Well, we're giving it an input of 2t. So everywhere we see this t, we replace it with 2t. Alright, so now I don't have to create a table to take 2t times 2t times 2t. 2 cubed is 8. T cubed, well, t to the third power. 2t times 2t. 2 times 2 is 4. T times t is t squared. And we're pretty almost done. I claim that what's going to come out of this assembly line, this function of f composed with g of t, is going to be 8 times t cubed plus 8 times t squared, because 2 times 4 is 8. So let's look and see, is that a choice? And there it is, choice A. Alright, so I hope that helps. Let's look and see, are there any other interesting ones? This one's the easiest way because we're plugging the more complicated function into the easier one. That's going to be simple for you to do. These guys are both linear functions. They're going to be pretty simple. Now, as soon as I say that, though, if you have questions about it, well, just ask me, and we can do it. Because you have the answer key. You know what you should expect here. All right, so this one, I'm almost positive that all classes asked me about this one. They saw the fraction and immediately knew to ask about it. So I did that in class. G composed with itself. So I'm going to stop the video here. I can definitely do more if you need me to. Alright. And that's just 2 linear ones. That one's pretty easy. Alright, so I hope that helps. Don't be afraid to ask me to do more. It may be time consuming, but I don't mind doing it for you. Alright, talk to you later.